Here's an example from 12.7 where we're going to eventually look at some problems referring to conditional probability. But first of all, let's look at what's given. We have a table, and you can look through the meals or lunch and dinner, and then other categories of having either good service or poor service and totals. So the question first asked is if one of these patrons is selected at random, find the probability that their service was good. So there is no condition that's given on this one. We're simply finding the probability that their service was good out of the total number of patrons. So to find the probability that they had good service, we look at out of the total number, and this 2,486 would be the total number of patrons. Those who felt their service was good was 1,459. So the number of successful events or favorable events would be the number who found they had good service, 1,459, out of the total number of patrons, 2,486. But now let's look at, well, what if we put a condition on that, or and have a given? And actually, before I move on, that was the fraction form. It was the simplest fraction form. There's no common factor between the numerator and the denominator. And then you could have also represented that as a decimal. And I've rounded that to 3 decimal places, so approximately 0.587 would be the probability that their service was good. But now let's look at, well, what if we're given that the patron came for lunch? So we want to find the probability that they got good service given that they came for lunch. So anything that's given, I actually always look at that first because that's going to narrow down what our pool is. So let's look at, given that they came for lunch, let's look at the total number of people who came for lunch. So if we look across lunch, the total who came for lunch was 841. Out of those, how many had good service? And that would be your 509. So what's given always goes in the denominator of your fraction. So we were given they came for lunch. That was the 841. Of those, how many had good service? And it was 509 out of 841. So that again is as simple as that fraction will go. No common factors. You could be asked to give that in fraction form or possibly in a decimal form. This one I've rounded to 3 decimal places. Okay, and then a similar problem, now notice the wording. That was the probability that they have good service given they came for lunch. What if though I said, what's the probability that they came for lunch given the service was good? So we always want to look at what's given first. Given the service was good is going to go in my denominator, the total number that had good service. And then we'll narrow this. So we've narrowed down the patrons, and then we'll narrow it down to those who came for lunch. So let's look at how many came and said their service was good. The total number who came and said the service was good. I'm going to change my highlighter. Actually, let me erase this. The total number who came and said their service was good was the 1459. And then out of those, how many came for lunch? And that was the 509. So what's given goes in the denominator. Given the service was good, that was the 1459. Out of that, how many came for lunch? 509. And again, that's as simple as that fraction will go. We can round it to 3 decimal places. So the probability that they came for lunch, given the service was good, would be 0.349. Okay, so just a little tip, if you'll head straight for what's given first, that's going to go in the denominator. That narrows down the pool of what the total number would have been. And then look for the probability from that and from the chart out of that total.